Welcome to the deep dive. So forget that old picture of automation, just rigid rules doing the same thing over and over.
Right.
We're really stepping into a new phase with these things called agents, software that seems to, well, think and act more on its own.
Uh-huh. And it's largely thanks to the big jumps we've seen in large language models, the LLMs.
Exactly. These systems are starting to handle tasks that are, frankly, surprisingly complex.
It's a real shift, isn't it? Moving away from just fixed programming towards something more, I guess, fluid, more autonomous problem solving.
Yeah. So our mission today for this deep dive is to really get under the hood.
Yeah.
We want to understand what these LLM agents are all about.
Yep. Figure out when they actually make sense to use, what their key parts are,
How you can structure them, maybe combine them.
and crucially, how we make sure they operate safely and responsibly. We're pulling our insights today mainly from this paper, A Practical Guide to Building Agents.pdf.
And for you listening, if you want to get up to speed on this quickly, get a solid handle on a complex topic without drowning in jargon, think of this as your shortcut, your direct path to understanding LLM agents.
Let's do it.
Okay, let's jump right in. First things first. What is an agent in this specific context? How is it different?
Okay, so fundamentally, an agent is a system that's built to get tasks done for you without needing you to spell out every single step.
So less hand-holding than traditional software.
Exactly. Traditional software often needs more direct step-by-step commands. An agent, though, you give it an objective, and it figures out the sequence of actions, what the guide calls the workflow, needed to actually achieve that goal.
Can you give an example of a workflow?
Sure. Think about, say, resolving a customer service ticket from the moment it comes in until it's fully resolved, or maybe generating a complex financial report by pulling data from different places. An agent could manage that whole flow.
Okay, so then what isn't an agent? Like, is my simple weather chatbot an agent? Or just using an LLM to summarize a document?
Good question. No, those typically wouldn't qualify. While they use LLMs and are useful, they don't control the entire workflow execution from start to finish.
Ah, okay.
An agent has a couple of defining traits. First, it uses an LLM, a large language model, as its core processor. It uses that LLM to manage the workflow, make decisions along the way.
Like what to do next.
Precisely. Deciding the next action, figuring out when the task is actually complete, and importantly, trying to self-correct or halt if things go wrong.
Okay, that's one trait. What's the other?
The second big thing is that an agent has access to and uses various tools.
Tools.
Yeah, think of them like its arms and legs or its connection to the outside world.
Yeah.
They let the agent interact with external systems, gather information it needs, or take specific actions. And it does this dynamically, choosing the right tool for the job, but always within predefined limits or guardrails.
Got it. LLM brain plus tools to interact. That clarifies things. So the million-dollar question then, when should you actually build an agent? When is it worth the effort compared to, say, traditional automation?
That really is the key question, isn't it? Because building agents isn't just a technical choice. It's kind of a shift in how systems make decisions.
How so?
Well, they really shine in situations where those older, deterministic, rule-based approaches just aren't cutting it anymore, where things are a bit fuzzier.
Okay.
Let's take that example of payment fraud analysis again. A traditional system. It's basically a checklist. Does it meet Rule A, Rule B, Rule C?
Right. If then else, basically.
Exactly. But an LLM agent can act more like a human investigator. It looks at the whole picture, the context of the transaction, tries to spot subtle patterns, things that might not neatly fit into a predefined rule but still feel suspicious.
So it's better for nuance, for situations that aren't just black and white.
Precisely that. The guide points out a few key criteria for when an agent might be the right call. First one's complex decision-making. So if your workflow involves a lot of judgment calls, or it has tons of exceptions to the rules, or the right decision really depends heavily on the specific context. Like maybe approving a tricky customer refund request. That's agent territory.
Makes sense. What else?
Second, difficult to maintain rules. Those systems. The ones with massive tangled webs of rules that are a nightmare to update and cost a fortune to maintain.
Oh, yeah. We've all seen those, like maybe compliance checks or vendor security reviews.
Exactly. Vendor security is a great example.
Right.
An agent could offer a much more flexible and adaptable way to handle that kind of complexity compared to constantly tweaking rigid rule sets.
Okay, complexity and brittle rules. What's the third one?
The third is a heavy reliance on unstructured data.
Meaning text, conversations.
Yep. Stuff like natural language in emails, reports, documents, or even back-and-forth chatbot conversations. If the core of the workflow involves understanding that kind of data, like, say, processing a home insurance claim based on a homeowner's written description and maybe some photos they uploaded.
Then an agent's language skills are a huge advantage.
Exactly. Because that's what LLMs are fundamentally good at.
Those are really clear pointers. Complex decisions, messy rules, unstructured data. So the takeaway is you really need to check if your problem fits these patterns before you jump into building an agent.
Absolutely. The guide stresses this. Validate these criteria first. Because if a simpler, deterministic solution can do the job reliably, stick with that. Don't overcomplicate things.
Right. Don't use a sledgehammer to crack a nut, as they say.
Precisely. Okay, so let's assume you do have a good use case.
Right.
What are the actual building blocks? What goes into making an agent?
Right, the foundations. The guide breaks it down into 3 core components. Pretty simple, actually.
Right.
First, you've got the model. That's the LLM itself, the engine doing the thinking, the reasoning.
The brain, basically.
Yep. Second, the tools. These are the external functions, the APIs, whatever the agent uses to actually do things or get information from the outside world.
It's hands and eyes.
Exactly. And third, the instructions. These are the guidelines, the rules, the guardrails you give the agent to define how it should behave and what its goals are.
Model, tools, instructions. Okay, that's a neat framework.
Yeah, and the guide even shows a little code snippet using OpenAI's agent's SDK just to make it concrete, like a super simple weather agent.
Oh, yeah. What does it show?
It just defines the agent, gives it basic instructions like you are a friendly weather bot, and then equips it with one tool, a function called getWeather. It really illustrates those 3 pieces in action.
Nice. Simple but clear. Okay, let's dig into each of those. First, selecting the model. It sounds like you wouldn't just grab the biggest, most powerful LLM off the shelf for every single task.
Right, that's a key point. Different models have different trade-offs, capability versus speed versus cost.
So some are better at really complex reasoning, but maybe they're slower or pricier.
Exactly. And others might be faster, cheaper, but maybe struggle with really intricate logic.
So the guide suggests
What?
using a mix.
Yeah, potentially using different models for different parts of a single workflow. Maybe a smaller, quicker model for simple stuff like understanding the initial user request or just fetching some data.
Okay.
But then for the really tricky decision points, like should we approve this unusual discount, that's where you might bring in the more powerful, more capable model.
Ah, okay. So tailor the model to this specific subtask.
Yeah.
How do you figure that out in practice?
The recommendation is pretty practical. Start by using the best, most capable model you can access. Use that to set a performance baseline, see how well the task can be done.
Right. Establish the ceiling.
Exactly. Then, once you know what's possible, you can start experimenting. Try swapping in smaller, faster, cheaper models for certain steps and see if they still meet your accuracy requirements.
And the key there must be having good ways to measure performance, right?
Mhm.
Evaluations.
Absolutely critical. Set up your evaluation metrics first. Aim for accuracy with the best model, then systematically optimize for cost and latency by trying smaller models where it makes sense. Don't sacrifice quality just to save a few pennies if it breaks the workflow.
Makes sense. Evaluate, baseline with the best, then optimize carefully. Okay, on to tools. You said these are how the agent interacts with the world.
Yep. They extend what the agent can actually do. Mostly, this means calling APIs to connect to other software, databases, websites, whatever.
Standard stuff.
But the guide also makes this interesting point about older systems, legacy software that doesn't have nice modern APIs.
Oh, what about them?
It mentions agents can potentially use something called computer use models. Basically, models trained to interact with graphical user interfaces, just like a human would, clicking buttons, filling forms.
Whoa, really? So agents could potentially drive old desktop apps.
Apparently so. That could
Yeah.
be huge for integrating with systems that haven't been updated for AI yet.
Yeah, no kidding.
Yeah.
Okay, so whether it's APIs or UI interaction, the guide probably emphasizes defining these tools properly.
Big time. Standardized definitions are key. Makes them reusable, easier to manage, easier for the LLM to understand what they do. Well-documented, tested tools are essential.
And does it categorize the types of tools?
Yep, broadly into 3 types. First is data tools. These are for fetching information, getting context. Think querying a database, reading a PDF, doing a web search.
Okay, getting info.
Second, action tools. These let the agent actually change things or perform actions in other systems. Sending an email, updating a customer record in a CRM, maybe even creating a support ticket.
Right, taking action. What's the third?
The third category is interesting, orchestration. This is where an agent itself can act as a tool for another agent.
Agents calling agents.
Exactly. We'll get more into that when we talk about the Manager pattern later. It's a way to build more complex systems.
Intriguing. Okay, data action orchestration. I bet there's another code snippet.
There is. It shows a search agent being given a web search tool to look things up online, and also a custom function tool called Save Results to, well, save what it finds. Makes it very concrete.
Cool.
But it also adds a little warning. If you find yourself piling dozens and dozens of tools onto a single agent, that might be a sign.
A sign that maybe the task is too big for one agent.
Exactly. Might be time to think about splitting the work across multiple, more specialized agents.
Good rule of thumb. Okay, that brings us to the third piece. Instructions. How critical are these?
According to the guide, absolutely vital, maybe even more critical for agents than for simpler LLM uses like just summarizing text.
Why is that?
Because the agent is making decisions, managing a workflow. Ambiguous instructions lead to bad decisions, workflow failures, unpredictable behavior. High-quality, clear instructions are paramount for reducing that ambiguity.
Okay, so how do you write good instructions? Any best practices?
Yeah, the guide offers several helpful tips. One great starting point is to use existing documents.
Like SOPs or manuals?
Exactly. Standard operating procedures, support scripts, policy docs that knowledge you already have, adapted into instructions for the agent. Like a knowledge-based article about handling returns could become the agent's script for that task.
Smart. Leverage what you've got.
Another tip. Prompt the agent to break down complex tasks. Instead of one giant block of instructions, guide the LLM to think step by step. Smaller, clearer steps are easier to follow correctly.
Okay, decomposition. What else?
Be explicit. Define clear actions. Make sure each step maps to a specific tool call or a concrete output. Don't just say, check customer status. Specify, call the customer status API with the customer ID and get the account active field.
Ah, precision matters.
Definitely. And finally, capture edge cases. Think about what can go wrong or what variations might occur. User gives incomplete info. System times out. Include instructions for how the agent should handle those common hiccups. Conditional logic, alternative paths.
Right. Anticipate the exceptions, because they will happen.
They always do. The guide even floats the idea of using advanced LLMs to help generate these instructions from your existing documents, which sounds pretty cool.
Automating the instruction writing. Interesting.
They give a sample prompt for turning a help article into a numbered list of agent steps.
Okay, so we've got the building blocks. Model, tools, instructions. Now, how do you actually put them together so they, run the workflow? That's orchestration, right?
That's exactly it. Orchestration is all about the patterns and structures you use to make the agent execute the workflow effectively.
And the advice is probably start simple.
Yep. Start simple, build incrementally. Don't jump straight to a super complex multi-agent setup if you don't need it. The guide splits orchestration into two main camps: single agent systems and multi-agent systems.
Okay, let's tackle single agent systems first. Sounds straightforward. One agent, one workflow.
Pretty much. One LLM brain equipped with its tools and instructions managing the whole process. The idea is you can often get quite far just by adding more tools to that single agent, which keeps things relatively simpler to manage, test, and maintain.
How does it actually run? Does it just keep going?
It operates in what the guide calls a run, basically a loop. The agent takes steps, calls tools, gets results, decides the next step, until it hits an exit condition.
Like what?
Could be successfully calling a specific final output tool, or maybe the LLM decides the task is done and generates a direct response to the user. Or it could hit an error, or maybe a predefined limit on the number of steps or turns.
Okay, controlled loop.
Yeah, and the guide mentions the runner.run function in the agent's SDK as the mechanism that handles this loop, running until that final output or direct message occurs. There's a tiny code example just showing how to kick off a run with a user's message.
Got it. But what if the logic for that single agent starts getting really complicated? Lots of if this, then that.
Great point. To handle that without immediately resorting to multiple agents, the guide strongly recommends using prompt templates.
Ah, like templates with variables.
Exactly. Instead of writing dozens of slightly different prompts for every variation, you create one flexible base prompt. Then you just plug in variables for the specific context, customer name, issue type, whatever.
So you manage the variables, not tons of separate prompts.
Right. It makes maintenance way easier. They show an example template for a call center agent with placeholders for things like the caller's name, how long they've been a customer, common complaint types. It keeps the core instructions tidy.
That's clever. Keeps things scalable for longer. So when do you cross the line? When is it really time to think about multi-agent systems?
The general advice is push the single agent as far as you reasonably can first, because multiple agents definitely add complexity, coordinating them, passing information, debugging,
Right.
more moving parts.
Yeah. But the guide suggests two main triggers for considering multiple agents. First, if your prompts or prompt templates are becoming incredibly convoluted with tons of conditional logic, just really hard to read and manage.
Okay, prompt complexity overload.
Second, if the agent needs a very large number of tools, especially if some tools are quite similar or overlap in function. Even after you've tried clarifying the tool names and descriptions, if the LLM is still struggling to pick the right one consistently, maybe it's time to split those tools across specialized agents.
Tool overload, basically. Got it. So if we do need multiple agents, what are the common ways to organize them, the patterns?
The guide highlights two main patterns they see used a lot in practice. First is the manager pattern, sometimes called agents as tools.
Okay.
And the second is the decentralized pattern, which involves agents handing off tasks to each other. They also mention you can think of these systems like graphs agents or nodes, and the connections are either tool calls or handoffs.
Okay, let's break down the manager pattern. What's the structure there?
So you have one central manager agent. Its job is to orchestrate the overall workflow. But instead of doing everything itself, it delegates specific subtasks to other specialized agents by calling them as if they were tools.
Ah, so the manager agent calls a translate to Spanish agent tool, which is actually another agent.
Exactly like that. The manager stays in control, calls the specialist agents as needed, gathers their results, maybe synthesizes them, and then presents the final output to the user.
Seems useful when you want one clear point of control and user interaction.
Precisely. The guide says it's good for workflows where one agent really should own the execution flow and the main conversation with the user. They include a diagram showing this kind of hub-and-spoke structure.
Then the translation example from the guide fits this perfectly right. A manager agent getting a request to translate into Spanish, French, and Italian?
Yep. It then calls the Spanish translator agent tool, the French agent tool, the Italian agent tool, gets the results back, and combines them.
Makes sense. The guide also briefly contrasts this SDK approach with more visual declarative frameworks where you have to draw out the whole graph beforehand.
Yeah, it frames the SDK as more code first, giving developers more flexibility to define the logic programmatically, rather than being locked into a predefined visual graph structure.
Okay, manager pattern is clear. What about the other one, the decentralized pattern?
Right. So in the decentralized pattern, you don't have that central manager. Instead, agents can directly hand off the entire workflow execution to another agent.
Handoff, like passing the baton.
Exactly. It's a one-way transfer. Agent A decides Agent B is better suited for the next part of the task, and it just hands over control. The conversation history usually goes along with it.
How does that work technically? Is handoff a special kind of tool?
Within the agent's SDK, yes, it's implemented as a specific type of tool call. When an agent calls a handoff function pointing to another agent, the system immediately switches execution to that target agent. The original agent stops, the new one takes over.
So the key difference from the manager is who's in control. Manager delegates via tools. Decentralized is a full transfer of responsibility via handoff.
You got it. It's less hierarchical. Think of it more like a team of peers. Agent A does its part, then passes the work to Agent B, who might pass it to Agent C.
When would this pattern be useful?
The guide suggests it's really effective for things like conversation triage. An initial agent figures out what the user needs, tech support, sales, order status, and then hands them off completely to the specialized agent who can handle the rest of the interaction.
Ah, like a virtual receptionist routing calls.
Perfect analogy. They show a customer service example with a triage agent, an issues repairs agent, a sales agent, and an orders agent. A user asks about an order, triage identifies it, and hands off to the orders agent.
And there's code for this too.
Yep. Shows the triage agent with handoff functions pointing to technical support agent, sales assistant agent, and order management agent. It walks through how a query about an order gets routed via handoff to the order management agent.
Interesting. Can the second agent ever hand back control, or is it always one way?
The guy actually notes that, yeah, the receiving agent could potentially hand control back if needed. Maybe if it realizes the first agent needs more info or something. So there's flexibility there too.
Okay, that covers single and multi-agent orchestration. Now, arguably the most critical piece, especially as these get more powerful, safety, guardrails.
Absolutely crucial. You can't just let these things run wild. The guide is very clear. Well-designed guardrails are essential to manage risks. Think data privacy, reputational damage, making costly mistakes.
And it's not just one guardrail, right? It's about layers.
Exactly. Layering is key. You need your standard software security practices first, authentication, authorization, access controls. Then you layer agent-specific guardrails on top of that for more robust protection.
The guide has a diagram showing this layered approach, right?
Yeah.
With different types working together.
Yeah, it shows how you might combine, say, LLM-based classifiers, simpler rules-based checks, and maybe even external services like the OpenAI Moderation API, all scrutinizing inputs and outputs. Defense in depth.
So what are the main types of guardrails we should think about?
The guide lists quite a few. There's a relevance classifier, basically, is the user's request on topic for what this agent is supposed to do. Or are they asking how tall the Eiffel Tower is?
Keep it focused. Makes sense.
Then a safety classifier. This tries to detect malicious inputs like jailbreak attempts or prompt injection attacks trying to trick the agent.
Okay, guarding against attacks.
A PII filter is important, preventing sensitive personal information from being exposed unnecessarily, either in the agent's processing or its responses.
Data privacy.
Crucial. Moderation, obviously. Flagging harmful content, hate speech, harassment, etc., using tools like OpenAI's moderation endpoint.
Standard content safety.
Then there are tool safeguards. This involves assessing the risk associated with each tool the agent can use. Like, is this tool just reading data? Low risk. Or can it modify records? Medium risk. Or can it, say, delete user accounts or transfer funds? High risk. Based on that risk level, you might require extra checks, logging, or even human approval before the agent can use a high-risk tool.
Smart. Risk-based access for tools.
Then you have your simpler rules-based protections, things like block lists for certain words, limits on input-output length, using regular expressions to block known bad patterns, your basic hygiene.
The deterministic stuff.
Exactly. And finally, output validation. Checking the agent's generated response before it goes to the user to make sure it aligns with brand voice, ethical guidelines, factual correctness, etc.
Wow, that's a lot of potential layers. It really highlights that safety isn't an afterthought here.
Absolutely not. The really interesting thing with agent guardrails compared to traditional systems is that they can be more dynamic, potentially using LMs themselves to understand nuance in inputs or outputs rather than just relying on rigid rules.
So how do you actually build and implement these? Do you need all of them from day one?
Probably not. The guide advises a pragmatic approach. Start by addressing the most obvious risks you can identify for your specific use case. Then, as you test and deploy, gather data on where things go wrong or where users try to misuse the system, and add more guardrails iteratively based on that real-world experience.
You'll learn and adapt the defenses.
Right. And always try to balance security with user experience. Overly aggressive guardrails can make the agent frustrating to use. There's a Python example in the guide showing an input guardrail.
Oh, yeah. What does it do?
It uses a separate, specialized churn detection agent to analyze the user's incoming message before the main customer support agent sees it. If the churn agent flags a message as indicating a high risk of the customer leaving,
It can maybe trigger a different workflow or alert a human.
exactly, it shows how one agent can act as a guardrail for another. It even gives examples of messages that should trigger it, like I'm thinking of switching providers, versus ones that shouldn't. Can you help me reset my password?
That's a neat implementation pattern. How does the SDK handle these checks? Does it slow things down?
The guide mentions the SDK uses optimistic execution. The main agent process starts, and the guardrail checks run concurrently, in parallel. If a guardrail detects a violation, it throws an exception to stop the main process. So it tries not to add latency unless a problem is actually found.
Efficient. And these guardrails can be just functions, or they can be other agents, as we saw.
Correct. Lots of flexibility in how you implement the policy enforcement. But even with all these automated checks,
There's still a need for humans.
absolutely, the guide really stresses this. Planning for human intervention is a critical safeguard. Don't assume the agent will handle everything perfectly.
So when should the system flag for a human to step in? What are the triggers?
Two main ones are highlighted. First, exceeding failure thresholds. If the agent gets stuck in a loop, keeps misunderstanding the user after several tries, or fails to execute a tool call repeatedly, basically. If it hits a predefined limit on errors or retries, it should probably escalate to a human.
Okay, persistent failure.
Second, high-risk actions. For anything particularly sensitive, irreversible, or with potentially large consequences, like deleting critical data, approving a huge financial transaction, maybe making a significant medical recommendation if it were in that domain, You likely want human review and approval, at least initially. Build confidence before fully automating high-stakes decisions.
Human oversight for the really important stuff. Makes total sense. Okay, this has been incredibly thorough. We've covered a lot of ground, from what agents are to how to build and safeguard them. To wrap up, what are the absolute key takeaways?
Well, I think the big picture is that agents are really a new chapter in automation. They're not just following scripts. They can reason, use tools flexibly, and handle complex workflows autonomously. That's a big deal.
Yeah, the reasoning part is key.
And remember when they're most suitable. Complex decisions, dealing with messy, unstructured data, or replacing those really brittle, hard-to-maintain rule systems. They're different from just single-shot LLM applications.
Right, it's about the whole workflow.
Building reliable ones comes down to those foundations. Capable models, well-defined tools, and super clear instructions. Get those right, and you're on a good path.
And choose the right orchestration pattern for your complexity level, starting simple.
Exactly. Single agent first, then maybe manager or decentralized if needed. And underpinning everything, guardrails, layered security, monitoring, and always having that human-in-the-loop plan, especially for risky actions.
Start small, test with users, iterate.
That's the mantra. Start small, validate, learn, and grow the capabilities. It's not about building a monolithic perfect agent overnight. It's more like moving beyond just if-then logic to actually handling the unpredictable what-ifs that often break traditional automation.
Definitely. It feels like with the right approach, these agents could unlock a ton of value, automating things in a much more intelligent and adaptable way than before.
I think so. The potential is definitely there.
Well, thanks for diving deep with us into LLM agents today. It's been really illuminating.
My pleasure. It's a fascinating area.
And thank you, our listener, for joining this deep dive. I hope it's given you a clearer picture. It's quite something, isn't it? Thinking about agents less like rigid checklists and more like, well, investigators, as you said earlier, and those different ways of having them collaborate, the manager versus the decentralized team. Lots to unpack.
Definitely.
Here's a final thought to maybe chew on. As these agents get smarter and more autonomous, how might that fundamentally change how we interact with software every day? Not just at work, but everywhere. What happens when our tools start having their own goals and plans?
That's a big question.
It is. Something to consider as this technology keeps evolving at lightning speed. We definitely encourage you to keep exploring this topic, see how it might apply to your world. The potential of intelligent agents is really just starting to show itself.